So there is a very well-known category of binary tree, and that is called as height balanced binary tree. So what is a height balanced binary tree? So height balanced tree is that where for every node, the height of left subtree and right subtree must not differ by more than 1 unit. This is the formal definition of height balanced tree. So height balanced tree is that in which for every node, the height of left subtree and right subtree must not differ by more than 1 unit. You know, I can formally write it in this manner. For every node, what should happen is that height of left subtree, which is an integer, minus height of right subtree. And I have to take its absolute value because I don't know which one is larger, which one is smaller, because all that I need to ensure is that their difference, their absolute difference is smaller than equals to 1. That's what we want. So let's take a quick example. So tell me one thing, let's say if you take this node, what is the height of left subtree? 2. And what is the height of right subtree? 2. What is 2 minus 2? It is 0. And 0 is smaller than equals to 1. It looks like it is a very simple problem, isn't it? Can I just find the height of left subtree by invoking height method for root left and then find the height of right subtree? So if I call this as h1 and I call the other height as h2, all that I can check for is this much. So I'll do this check only for the root. Will that be sufficient? The answer is no, it will not be sufficient because the question clearly says for every node, this condition has to be true. Okay, for every node, this condition has to be true. So if instead you have something like this, okay, if you perform this check only for the root, will this check be true or false? Only for the root, tell me. The check will be true. Why? Because the left height is 3 and the right height is also 3. But will you say this is a height balanced tree? No. What is the culprit node over here? Which node is not abiding by the rule? This 2 is not abiding by the rule because for this 2, the left height is 2 and the right height is 0, and 2 minus 0 is not smaller than equals to 1. Correct? So what you have to do is you have to perform this check for all the nodes. So you can solve this question exactly like diameter question. So at each node, you can first find left height, then you can find right height, and then you can check for the difference. But you know, you can play much smarter because if you take the approach that was our first approach of diameter, it will take you order n square, because from each node, you'll call height for its left child. Then again, you'll call get height method again and again. Rather, what you can do is in the height method itself, let's say you have invoked height call for this. Now, whenever you are at a node, you would know what is the left height and you would know what is the right height. Okay, you would know left and right height. So if you realize that this thing ever becomes greater than 1, then you can turn your answer equals to false. And this answer can be a Boolean variable, which you can again keep global or you can pass it by reference. Okay, so you let your get height method remain as it is. The only trick that you play is whenever left height and right height have been returned for a particular node, just check for their difference. If their difference exceeds 1, then you turn your answer variable to false. That's it.